Imagine looking up at the night sky, at that beautiful, hazy band we call the Milky Way. It's our cosmic home, a sprawling city of stars. But have you ever wondered what lies at its very heart, its downtown core? It's not a giant star or a bustling star cluster. No, it's something far more mysterious and powerful. Lurking in the center of our own galaxy is a monster, a supermassive black hole named Sagittarius A, pronounced Sagittarius A star. Now, when you hear black hole, you might picture a cosmic vacuum cleaner, sucking up everything in its path. And while they are incredibly powerful, the reality is even more fascinating. Sagittarius A, or Sgr A for short, isn't just a void. It's the gravitational anchor of our entire galaxy. Every star you see, every planet, even our own solar system, is on a grand cosmic dance around this single invisible point. So, how big is this galactic monster? The numbers are almost too big to comprehend. Sgr A sign has a mass equivalent to 4.3 million times the mass of our sun. Let me repeat that. 4.3 million suns, all crushed down into a single point of infinite density. Imagine taking every single person in a major city and squishing them into the size of a marble. That gives you a tiny glimpse of the kind of density we're talking about, but on a stellar scale. Despite this incredible mass, the actual size of the black hole itself, its event horizon, is surprisingly small in cosmic terms. The event horizon is the point of no return. Once anything crosses that boundary, light, matter, anything, it can never escape. The diameter of Sgr A's event horizon is about 24 million kilometers. That sounds huge, and it is. It's about 17 times the diameter of our sun. You could fit about 17 suns side by side across it. But remember, this relatively small region contains the mass of over 4 million suns. Now, let's put that into perspective. If our sun were suddenly replaced by Sagittarius A, its event horizon would extend out almost to the orbit of Mercury. The inner planets, including Earth, would be gone in an instant. But don't worry. Sgr A is a safe distance away, about 26,000 light-years from us. That means even if you could travel at the speed of light, the fastest speed possible in the universe, it would still take you 26,000 years to get there. We are perfectly safe out here in our quiet, suburban spiral arm of the galaxy. So if Sgr A is a black hole, and black holes are, by definition, black, because not even light can escape, how do we even know it's there? We can't see it directly, but we can see its effects on everything around it. It's like trying to find a person in a pitch-black room. You can't see them, but if they start throwing things, you can track their location by watching the objects fly through the air. For decades, astronomers have been watching the stars orbiting the galactic center with incredible precision. Using powerful telescopes like the Keck Observatory in Hawaii and the Very Large Telescope in Chile, they've tracked the paths of these stars for years. One star in particular, named S2, has been our golden ticket. It orbits Sgr A once every 16 years on a wild elliptical path. By tracking S2's orbit, astronomers could apply basic laws of physics, the same ones that govern the planets in our solar system, to calculate the mass of the object it was orbiting. The only thing that could be that massive and that compact was a supermassive black hole. It was a stunning confirmation of decades of theory. But seeing the stars orbiting it was just the beginning. The real breakthrough came in 2019, and then again in 2022. You might remember the first ever image of a black hole, the one at the center of the M87 galaxy. That was captured by the Event Horizon Telescope, or EHT. The EHT isn't a single telescope. It's a network of radio telescopes scattered all across the globe, all working together. By combining their data, they can create a virtual telescope the size of the Earth, giving us the power to see incredible detail from thousands of light-years away. After their success with M87, the EHT team turned their sights homeward to Sagittarius A. Capturing an image of our own black hole was actually much harder. Sgr A is much smaller than M87's black hole, and the gas swirling around it moves so fast that its appearance changes from minute to minute. It was like trying to take a clear picture of a spinning top, while M87's black hole was more like a slow-moving carousel. But in May 2022, they did it. They released the first ever image of Sagittarius A. It wasn't a picture of the black hole itself, but of its shadow, silhouetted against the glowing, superheated gas swirling around it. We saw a dark central region, the black hole's shadow, surrounded by a blazing, lopsided ring of light. That ring is made of plasma, heated to billions of degrees as it's whipped around by the black hole's immense gravity, moving at a significant fraction of the speed of light. Seeing that image was a profound moment for humanity. For the first time, we had direct visual evidence of the giant that governs our Milky Way. What does Sgr A do all day? Well, for a supermassive black hole, it's actually pretty quiet. It's not actively gobbling up huge amounts of matter. It's more of a snacker than a gourmand. It occasionally pulls in small clouds of gas and dust, or an unlucky star that wanders too close. When this matter gets pulled in, it forms that swirling accretion disk, which heats up and emits radiation across the spectrum, from radio waves to X-rays. This is the radiation our telescopes detect. These occasional flares are like cosmic burps, telling us that Sgr A has just had a small snack. The study of Sagittarius A is far from over. Scientists are still trying to understand how it formed in the first place. Did it start from a single giant star that collapsed and then grew over billions of years? Or did smaller black holes merge together in the early universe? And how does its presence affect the formation of stars in the galactic center? These are some of the biggest questions in modern astronomy. The James Webb Space Telescope is now giving us an even clearer view of the galactic center, peering through the thick dust clouds that have hidden it from us for so long. Every new observation brings us closer to understanding the life cycle of galaxies and the role these incredible objects play in the cosmic ecosystem. So, the next time you look up at the Milky Way, remember what lies at its heart. It's not just empty space. It's a place of extreme physics, a gravitational titan holding our entire galaxy together. It's a reminder of the vast, mysterious, and beautiful universe we are a part of. We have a monster in our celestial home, and we're just beginning to get to know it. Thank you so much for joining me on this journey to the center of our galaxy. If you enjoyed this cosmic exploration, please hit that like button, subscribe for more adventures into the unknown, and ring that notification bell so you don't miss our next video. Until next time, keep looking up.